Okay, example number 2. Find the equation of the tangent line to y equals sine x divided by cos 2x at the point where x is equal to pi on 6. Okay, so the first thing that I'm going to do is find my slope, which is my first derivative, which looks like it's going to be the quotient law. So y prime, again, is representing my slope, is equal to low, which is cos 2x, d high, so the derivative of sine x is cos x, less, so subtract, the high, which is sine x, multiplied by the derivative of the bottom, which is the derivative of cos 2x. So he will be negative sine of the argument multiplied by the derivative of the inner 2. So you have to be super careful on these guys that have an argument that has more than just an x. So he's going to have that funky chain. Okay, so this is our d outer, d inner. Do not forget your dinner, right? And then all of this has to be divided by the bottom, cos 2x squared. Okay, so really there's not much to do with this. The calculus is done. I might just tidy it up a little bit so it's just easier to substitute in. So I have cos x multiplied by cos 2x. Two negatives make a positive, and then I have a 2 sine x sine 2x, all divided by this cos 2x squared on the bottom. And what I have to do to find the actual slope is evaluate this at the point of tangency, which is pi on 6. So when x equals pi on 6. So I'm putting pi on 6 into this. So the slope will be equal to cos pi on 6 multiplied by cos 2 pi on 6 plus 2 times sine pi on 6 multiplied by sine 2 pi on 6 divided by cos 2 pi on 6, and all of that on the bottom has to be squared. So hopefully you recognize that those 2 pi on 6's actually reduce to pi on 3. Okay, so these are really pi on 3. And so I'm looking on my unit circle at both the coordinates at pi on 6, which would be root 3 on 2 and 1/2, and the coordinates that are happening at pi on 3, which would be the opposites of those, 1/2 and root 3 on 2. And then I'm going to fill in those down here. Okay, so cos pi on 6 is the x, root 3 on 2, multiplied by cos pi on 3, also the x, but the x at pi on 3, which is 1/2, plus 2 times sine pi on 6 would be the y coordinate, so 1/2 at pi on 6. And then I need the y coordinate at pi on 3, which is root 3 on 2. And then all of that has to be divided by the bottom, which is cos pi on 3. So the x coordinate at pi on 3 is 1/2, and that has to be squared. So let's see if we can find a decent number out of this. So we have this is equal to root 3 on 4 plus 2 root 3 on 4. And I purposely did not cancel that out so that I would have a common denominator to work with, divided by 1/4. So this is equal to root 3 plus 2 root 3, because I left them with a common denominator, is 3 root 3. So we're adding our coefficients there. 1 plus 2 makes our 3, with a denominator of 4, multiplied by, kiss and flip, 4 on 1. So then my 4's can cancel, and the slope is then equal to 3 root 3. So that's just step 1, finding my slope. Now step 2 is to find the equation. Okay, so what do I know? I know my slope is 3 root 3, and it's happening at the point of tangency of x is equal to pi on 6. And I want to find my y value. So the y has to be evaluated in the original function, which was sine x, so sine pi on 6, divided by cos 2 pi on 6. And sine pi on 6 is equal to 1/2 divided by cos, that's actually pi on 3. Remember, 2 pi on 6 reduces to pi on 3. And that also is 1/2. So 1/2 divided by 1/2 is 1. So that's just telling me that my point of tangency is pi on 6 and 1. Point of tangency. Okay, so I have my slope and I have my point of tangency, and now I can go and make my equation. Y minus y1 is equal to m times x minus x1, and fill in all those pieces that I just figured out. So y minus 1 is equal to my slope, 3 root 3, multiplied by x minus pi on 6. And from here, I'm going to distribute, and this is going to be ugly looking because we got radicals and pies. All right, y minus 1 is equal to 3 root 3 times x minus 3 root 3 pi on 6. Very ugly. That 3 on 6 could reduce to 1/2. Okay, so that's going to reduce to 1/2. And then I'm going to multiply all of this by 2 so that I can get rid of that denominator. So now I have 2y minus 2 is equal to 6 root 3x minus root 3 pi. Very ugly looking. And again, if we're going to put this into general form, we want to have the coefficient on x to be positive. And so in this case, I'm going to move everything to the right. So I have 6 root 3x minus 2y minus root 3 pi plus 2 is equal to 0. And there's my lovely general form equation for the equation of this tangent line of y equals sine x on cos 2x, where x is equal to pi on 6. That's the point of tangency. Very ugly looking equation, but we found it. Well done. Okay, the last piece is going to be our curve sketch analysis. So let's get started on this and see how we do. You might want to give this a try again on your own if you wish, and then see how far you can get. We're going to look at all 8 pieces. So we're going to use that procedure that you learned in chapter 5 to sketch f of x is equal to x minus cos x. And they have given me a restricted domain. So when I look at this, the first thing to do is to look at your domain, and they've given it to me. So I'm looking at negative 2 pi to 2 pi. That's my domain. All right, so then I'm going to look at, can I find x and y intercepts from this function? Let's see. So second thing to look at is intercepts. And sometimes on these trig graphs, it's tricky to find. And so you just do your best and see if you can figure it out. Okay, so to find an x-intercept, we would set y equal to 0. So 0 is equal to x minus cos x, and that's going to attempt to be solved as cos x is equal to x. And I'm like, I don't know, I can't actually find that exactly without my graphing calculator. So in this case, I'm just going to be like, that's not going to be helpful. That's not something I can figure out without my graphing calculator at this point in my math knowledge. So let's see if I can find a y intercept. So this would be to figure out when y is equal to 0. So I have 0 minus cos 0. All right, so remember that's 0 radians. That's an angle. So I'm going back to my unit circle, and I'm looking at the coordinates at 0 radians, right? And because I'm working with the cos function, I want the x, okay? So that means that cos at 0 radians is 1. So 0 minus 1 tells me I have a y-intercept at negative 1. Okay, so at least I found 1 point. So this is 0, negative 1. I know something. That's wonderful. All right, what's the third thing we're going to look at? We're going to look at symmetry next. Okay, so remember, we're going to replace x with negative x and see what's happening in our function, if we can figure anything out. So f of negative x would be negative x minus cos of negative x. And so I can factor out a negative 1, and that would leave me with x plus cos of negative x. And so I don't get the same function. I'm not getting anything here. So this is neither types of symmetry. And then number 4, we're looking at asymptotes, and we don't have any denominators, so that's lovely. We have none to worry about. And so we're going to look then at having to take first derivative so that we can look for intervals of increase and decrease, and also find our max mins. In order to do those steps 5 and step 6, we need that first derivative. So I'm going to pause the video here, and I'll come back with video number 3, and we'll look at finishing this question. Give it a go on your own and before you look at video number 3 and see how well you do.